Be done before 10:30. Okay, we're going to talk, this is the last piece of resistance-only circuits, okay? As I said for the class while I was not in the live stream, next week we will be using Raspberry Pis and doing soldering. So bring your Pi to class if you're going to be here. Okay. Now, because this is the last resistance-only circuits lecture, this is the last time we're going to be comfortable in this class. Things get dark really quickly. If you don't understand Thevenin equivalent circuits, if you don't understand equivalent resistance circuits, if you don't understand both of those concepts, you are going to struggle really fast in 2 weeks after we get done with soldering and Raspberry Pi stuff, okay? That's how fast the pace of this class goes, all right? When we get to talking about capacitors and inductors, that whole, there's no voltage across this component, therefore there's no current, that stops being true, okay? Because then all of a sudden you have to be studying, all right, what does the graph of the voltage versus time graph look like? Okay, it looks like this. All right, what does that mean for the current versus time graph? And where's my current? And what time does it, where is it at? And it gets into this quickly, okay? I have posted a whole bunch of videos on YouTube at this point. You have access to them. If you feel uncomfortable about any of my lecture topics, you can go back and watch them. We have to keep going forward, okay? This class is a 4-credit-hour class. This is a hard class, okay? This is not baby science. All of you got into here because you put in the work to get to this point. My job is to challenge you, okay? To continue to push you. And I will do that. And you will be pushed, okay? If nothing else, at the end of this class, I don't care if you hate circuits. You have to take this class anyways, because it is important to understand higher level concepts in things like systems and controls, and basically have a broader understanding of physics. I don't care if you hate this class, but I want you to learn something. And I want you to grow as young students in your understanding of these topics, okay? So, I have no problems making this hard. It will be hard. You will need to study, okay?
The unintended would be dark. You don't know.
Well, we are going to be using LEDs, so I guess it's not going to be that dark.
When the circuits don't work.
That was unintentional. Thank you. All right, let's talk about a Wheatstone bridge quick. FYI, the book gives you one example of where this is used. As far as I can tell, there is one example of where this is used. I've only encountered a Wheatstone bridge once in my entire life. That's it. And it was that one time was the one example the book gave. Okay, basically the way the Wheatstone bridge looks is you have a system that has 4 resistors connected in a diamond. That's a Wheatstone bridge. R1, R2, R3, R4. That is a 5. Nice, thanks, Gail. In the middle, you have a detector. Basically a multimeter. Okay. The goal here is to identify what each of these resistances are. Okay. If a resistance is larger on one side, you can figure it out. If it's larger on another side, you can figure it out. The one use that the book gives you is that it is used in calculating strain gauges. That's the only time I've ever seen it used. For those of you in mechanics and materials right now, a strain gauge is how you determine the strain of a material, which then you can use to calculate the stress at that location. That's it. That really is it. According to the book, there is a calculation that you can use specifically dealing with a Wheatstone bridge. If you don't know the resistance at, here it says R4, which is this one.
The temperature and light as well.
It can be, but we have better sensors for both of those.
I'm just saying.
I know. Thermistor is a way better way of measuring temperature. Does not require this.
If you're ever stranded on an island and you only have a Wheatstone.
You only have a Wheatstone bridge. Yeah, for that one situation where you, for some reason, this is it. You know, your entire life is here. The equation the book gives you is R4 is equal to R3 times R2 over R1. Yeah, R2 over R1. Okay? Which, the equation here is, the nice piece about this is oftentimes what's done in strain gauge measurements is you will actually take a strain gauge and you will put it into a square like this. You will apply power to these two ends. The strain gauge measurement here gives you the strain in one direction. This also gives you the strain in that direction. The strain gauges here give you the strain in the exact perpendicular direction. This, by the way, is why it's drawn this way and not a smarter way. Because, by the way, if you were to if an electrical engineer were to draw this, it's this. But they don't draw it like that because this is how the strain gauges are installed in real life. Okay? Yeah. Kind of. So ideally what you end up with is if R2 and R1 are the same, then R3 and R4 should be the same. If there is any difference between the two, R1 and R2, you will get a difference between R3 and R4. Forces that to happen. Okay? That's it. I'm not even going to give you an example because when you understand strain gauges, you'll have to do these calculations if you ever do strain gauges. You have a question?
Yeah, how can I know, like, if I want to find R4 equal to this can be R2 multiplied by R3 over R1. So how do I know? How can I know like this equation? Like which one is that R3, R3?
Like this? How do you know what the values for the resistances are?
If I want to find R4, I have to multiply the if part R3, or can I multiply by R2 or?
Yeah, the idea here is if you the way that the book frames this is if you were to connect a line here and there is no current flowing between these 2 points, this has to be true. So, like, the way that it's presented in the book I don't like, but the idea is you would adjust the resistance until you get no current here. And when that happens, you would probably already be given the values of R1 and R2 and R3. and you would just have to figure out the value of R4 based on this calculation. So you would be given these.
Can I,
Do you want to come up here and draw it?
yeah, I don't know. R4 can be like, if I want to find R4, can I write this too? Oh,
Multiply, yeah. Yes, you can. Yeah, you can arrange them.
can I?
Yeah.
Okay.
Yep. Yep, perfectly valid. Ooh, we got another Russian comment. I'm not going to make you do a problem with this. Again, this is, if you were to take a class where you have to do strain gauge measurement, this is going to be explained a lot better. I don't want to have to try to explain mechanics of materials to you and why this is true, why this is used. You just know that this is there, okay? That's really all I wanted to say. Just for clarity of information, just to be like, hey, look, this exists. Any other questions on this? Okay, we won't use this. All right, so to wrap up resistance-only circuits, the two pieces that are absolutely quintessential that we studied are equivalent resistances and Thevenin equivalence. Okay? You should feel very, very comfortable with those. Additionally, we have some pieces that we can plug into both of those types of systems, which are power calculations. You should feel very comfortable figuring out what is power in, what is power out, how do we take power flows, figure things out about them, okay? You should feel very comfortable determining parallel and series circuits. Okay? Can you identify if a thing is in series, if it is in parallel? You should also be very familiar with calculating node voltages. Okay? Can you figure out what the voltage is at a certain node at a certain time? Okay? That's the takeaway from this. If you understand those 5 pieces really well, you will do fine on the exam when it comes to resistance-only circuits. Okay? You basically know everything that I want you to know about resistance-only circuits. Any questions? I'm going to be assigning your quiz. You're going to have to do the quiz before Tuesday night, so you can come talk to me. You will have a reading assignment, which is going to involve you watching 2 videos. Please try to get that done before class on Tuesday, because they're all about how to solder and how to use the Raspberry Pi. And I'm going to assume you watch the videos before class so that I don't have to go over some of that material myself. Okay? I will send the link out to the program of how to flash a Pi. It would be really nice if you flashed your Pis before Tuesday's class.
What? Exposed to your Pi.
No, flash the operating system onto the Pi. You can blame electrical engineers for that term. Also, we're going to talk about flip-flops in this class. You can also blame electrical engineers for that term. But it's a way more fun term. All right. We'll call it for today. I will see you all on Tuesday.